Hello, everyone. Good afternoon and Happy New Year to those I haven't seen since the start of the year. We want to welcome you all to the first of our seminars for this semester. And we're happy to welcome visitors to the department, visiting researchers. We have with us today Dr. Victoria Dominguez Almela and Jose Lopez Portillo. We want to welcome them to the department. So they are part of a bigger research group, and today they will present on developing citizen science monitoring capacity for adaptation to seaweed influxes. Right, so developing citizen science monitoring capacity for adaptation to seaweed influxes. A little bit about them. Dr. Almela's research focuses on biological invasions and their impact on the ecosystem and society. She does this by integrating tools such as modeling and stable isotope analysis and citizen sciences. Jose is working on the development of image capturing systems and computer algorithms for automatic study of coastal processes. So he is currently doing his PhD and it's focused on sargassum analysis in the Mexican Caribbean. He intends to obtain path and area measurements from the static near coast images. And he's also involved in generating and analyzing citizen science images for sargassum monitoring. So these are our presenters today. Let us welcome them. We thank them for coming. I will now turn over our presenter, Dr. Victoria Dominguez Almela. Yes, please. I will open your
I'm not see there's Zoom settings in this. And sometimes that doesn't work. Yeah. It's because it's there. Oh, it's open. Okay. It's fine. You can leave it like that. Hopefully it works. Maybe it doesn't. Maybe here. Right. Thank you for the warm welcome, everyone. It's a pleasure to be here today, sharing with you some of the stuff that we have been working on lately. As you have introduced, I'm just an aquatic ecologist by training. What I'm showing you today is a new skill that I'm sort of like learning about slowly, and Pepe Toño too. That is citizen science. That's what I'm going to be focusing on the first half of the talk. And then Pepe Toño will go into more sort of sophisticated analysis of the stuff that we are going to be presenting today. So just to open a bit broadly this talk, we are seeing nowadays a lot of changes going on in our environment. What you see on the screen now is right on the left, we have Rome in last summer. showing those 46 degrees Celsius. Right in the middle, we have Sicily, also Italy, also last summer, showing those wildfires going on. And the last picture on the right is Milan, also Italy, also last summer, but showing those torrential rains. And this is just an aspect of those environmental changes that we are seeing changing so rapidly that not everyone is going to be able to adapt quickly or have the resources to do something about it. We are going to be focusing today on the coast, one specific problematic on the coast. And as I said, I'm going to be sharing with you a bit about citizen science, which is basically having the public, having people helping and on board of science, of the research projects. And we want to see if we can create knowledge, motivation, and interest for those people, and hopefully do something nice together. So as I said, we are going to be focusing on one problem today. A recent literature review that we have done has shown that the world is suffering from a lot of type of algae invading and blooming in different areas of the world. And we focus only on the brown algae. We already have nearly 30% of our world coast being affected by them. And this is forgetting about the green tides and the red tides. So it's quite a huge amount, looking just a few events in that review. On the pictures, I guess some of you recognize what I'm showing there. So on the picture on the left, we have the sargassum. That's a news that came into the Guardian that we read a few months ago in the UK, where they basically talk about how badly impacted the Caribbean is by this seaweed, this sargassum seaweed, which is a brown type of seaweed that always gonna float in the sea, and now is impacting quite a lot of your coast, as you already know. And if you go into literature, you find quite a lot of information. A lot of researchers focusing on this problem is so huge. There's quite a lot of people trying to obtain the knowledge to try to do something about it. But the Caribbean is not the only place that is being affected. We also have West Africa, where this sargassum is bleaching. And if you do the same exercise and go to literature, you will see that there's not that much knowledge out there about what's going on in that part of the world. So if you try to mimic some of the studies that have been done for the Caribbean, for example, using some satellite images, you will encounter problems like West Africa is covering clouds most of the year, so it's very difficult to see what's going on, when is that sargassum arriving, how much is arriving, or where exactly is arriving. So very limited knowledge that we have there, and that's why we came with the idea of, can we use citizen science? Can we use people that are living there all the time and they see the problem every day to help us understand about the sargassum in those areas where we don't have enough data? And can this be a tool that also will help them to strengthen the local capacity about this problem? So that's what we tried to do. And we traveled to Ghana to do this study. So this is Accra, the capital. But we went over there in those remote areas of the West, Sansule, Beijing, and Siama. It's quite a long way from the capital. It's around 9 hours by bus. So quite a long trip. And they are quite isolated. So you have to imagine they are poor under the poor. It's really a basic condition where you have there. They don't really have that much contact with the capital either. So they have the problem of the seaweed arriving and no one is listening to them. They feel lonely. They feel like they have to deal by themselves with something that they've never seen before. So we are talking about villages that they rely on the fish that they catch every day to eat that day and to make them money for that day. So the fact that for some months over the year, they start breaking their nets because there is a lot of seaweed, or they drag the seaweed into their nets with the fish already suffocated within that seaweed. That's a problem, real food insecurity problem that we are having over there. So we travel on those areas and we start talking to people. We try to understand what they need, what was the knowledge around this problem, if they could share with us what they needed. And you would be surprised that some of them, they wouldn't know what a seaweed is. They would basically define seaweed as a disease from the sea. So they wouldn't touch it, they wouldn't go to the beach anymore. They also linked, so when the sargassum started appearing on those beaches, coincidentally, an oil company started drilling on the seabeds. So they made the connection, and it is quite difficult to try to explain science, because they already have very hard in mind that that's the connection. That's why they have the seaweeds. So we thought, how do we share the knowledge? How do we get into the community for them to understand that, well, that is something else going on? So the science teachers in the schools in those areas were quite welcome about the whole science behind all this. And they sat with us and they told us, right, we are open to try to teach our kids about what's happening in reality, so we can have that first seed that will spread into the community. And we co-created together some, we call it sargassum material for the schools, where they have activities and they can start learning a little bit about it. But as I said, I mean, we are scientists, and I'm not there every day, and I'm very interested as well about the data that I don't have. So the way that we went around that is we installed those metal posts on the beach that you can see there. We installed 3, 1 per community, and it's essentially very low tech. It's a metal post with instructions that basically tell you to scan a QR code, and then it will give you a picture mode. So you just place the phone into that hole, make the picture, and it will then save that picture into a cloud that is open access. Anyone in the world is going to be able to see what's going on in that particular bit of Ghana. That's how the app looks like. And it's an initiative that is currently widely used for understanding coastal erosion globally. And it's called, we have the name over there, it's Coast Snap. So widely used. We haven't really invented the wheel here. We talked with the people that were with this initiative, and they were quite interested in to see if we could use it for monitoring the seaweeds. But also, those pictures are there. So anyone working on coastal erosion could potentially use those as well. So there we go. So we installed the points, we developed that material with the teachers, and then we went out as well to talk with the people, to talk with the kids, to see if we could understand the perception that they have about the seaweed. And I will come back to this point a little bit later, just to show you a quick snap of how a Siama looked like. So I just randomly extracted some of the pictures, but to give you an idea, we will have few pictures per month. I think at least we have once a week a picture. We have already a year data. So if this was, imagine this is like the mean of each of the months, we could then start saying, well, it looks like it's a peak of sargassum in August, a little bit in September, and that's it. That may be the seasonality that we have sargassum in Ghana, in this particular region. Don't just take it as an example. As I said, I randomly selected those pictures that is not analysis being done yet. But that's the idea behind this. So from there, we thought, this is actually quite interesting approach. So we started expanding a little bit and see if we could still collaborate with the Quad Snap people and try to have definitely that approach used for monitoring algae in general. It doesn't have to be sargassum only. So we have Southampton, my university is somewhere over here at the south. An hour away from there, we have what we call Poolhard, which is a very important place for migratory birds in South England. And lately, it's been a proliferation of ulva, what we commonly call sea lettuce. And that proliferation is making an impact on the invertebrates of those areas, and therefore on the birds that are trying to prey into those invertebrates. So we built another station there, and we did a very similar approach as in Ghana, and we started working with the schools around. We created material with them. We are giving different sort of like environmental lesson. This is kind of like an after a school club where they can, those that are very interested in science will stay in the school and join us during those workshops. Then we got contacted by the UNAM in Mexico, where Pepe Toño is coming from, and they mentioned that they also wanted to expand something like that in Mexico because it's something that they would be very interested as well to develop some oceanographic models. So we thought that looks good as well. So we have already 3 stations in Mexico, 2 in Puerto Morelos and 1 in Excavaca. And again, same approach. We went to the schools, we tried to engage with the people. So it's not just us asking the community, can you come and take pictures? It's more sort of like 2 ways. So I'm giving you my knowledge as a scientist. What do you want? What would you like to share with your students? How can I help you? So there is a 2 ways win there. So we talk with the schools, not only in those 2 places, but we went to Cozumel, where we expect to install 3 stations in April coming. And we also talk with some schools in Acumao, hopefully to install some more. Material is being developed in Spanish for them as well. So similar work in a different part of the world. And the reason we are here is because we have also done some work with you guys here in Port Royal, and we built our first station to monitor sargassum. And we had our first school visiting and be trained for how to use the station. Hopefully, we will be building more along the coast and getting on board more schools, more people, hopefully getting that seed out. So the families, friends, they all, whenever they see the point, they scan the code and make that picture and that contribution. I said before, we were asking people for some of their thoughts on the perception. This is just very preliminary result that I made with some of the data we have from Ghana. So it's a word cloud, the words that are bigger, the ones that appear more times in that surface. And you can see words like bad, fish, fishing, smell. You have here quite a lot of those here as well. But you may notice something interesting. We see positive, useful. When you dig into that data, what you see is that the kids are actually the ones saying those words because they have been already trained and shared with some of the knowledge of sargassum. So they know there are people somewhere in the world doing something or trying to create something. So that's where those words are coming from those kids that already know about sargassum. So we think that so far, I mean, it's so preliminary, but we think citizen science can be a very interesting tool for adaptive capacity. it's building those long-term relationships with the community. They feel part of something that is bigger. They feel part of the solution potentially. And so far, the experience that we had is that people really want to collaborate and they really want to make those pictures and collaborate. The example in Ghana is very funny. So if you go into the cloud and try to see the pictures of one of the communities, you will see that on Monday, you have suddenly 20 pictures taken roughly at the same time. And that's basically that the teacher was teaching about sargassum. It took the whole class to the point and they all had a go at uploading the pictures. So we think it's interesting. It's something that we should be doing more often, that is involving everyone into the science process. And until here, I'm going to stop talking and I'm going to give this the floor to Pepe Toño. He's going to talk to you a little bit more about what we are doing afterwards.
So, hi everyone. My name is Pepe Toño. I'm a former electronic engineer there in UNAM. After that, I started studying my master's degree in image processing for coastal process. So I will talk to you about a little bit of analysis of coastal images. The first thing is why we are going to use this approach to study some of the process. It helps us study the process without interfering with them. You know, you don't have to go in the camp. You don't have to store the little things there. You don't have to put a foot on the place. You can do it automatically, so you don't have to worry about how many times you have to go. You don't have to worry about going like so much times. You can cover big areas related to the not automatic part that you have to go and do it by yourself. You can cover big areas compared with that. And the images can be reanalyzed for different purposes. A good example of this is the image that we have in the presentation. That is the coast of Puerto Morelos near the Institute of Oceanography there in Puerto Morelos of UNAM. You can see that the first purpose the camera was located there was to study the line coast and the advancement and the movement of the line coast. Then in 2015, when the first sargassum bloomed there in Puerto Morelos, the camera and the images can also be purposes for an analysis of the sargassum and the movement and how it behaves near the coast. So then we will change the main purpose of the camera, and we can use the same images from both purposes. So it can be related to another kind of chronology in there. So I will talk to you about a little bit of how to get the images to analyze different things. We have the satellite detection. You can take images from satellites. These normally are like multispectral images, that meaning that you capture different lines of the spectrum of light, depending on the phenomena you are looking for. Some of the advantages of satellite detections involves that you can process larger areas. You can process like kilometers around where you are looking for. And you can, in the case of sargassum and other events, you can long estimate how it's going to move and where it's going to get, depending on how much your definition is in the image. Some disadvantages talking about coastal processing is that there's no images near shore. So near shore, you most likely have too much noise in the images because of the light being reflected by the sun, sometimes the buildings that are nearby. So normally they don't do like the images near shore. You don't really have real-time images. You have to wait until the satellite skies over that area, like every week, every day sometimes. And you also rely on climate. So if there's a cloud that is just over the area you're studying, it's very difficult to get another one to the next part, you know. And the images obtained by this way, they are big, so you have to get big computers in there, like big storage. It's complicated at sometimes to get these kind of resources. So sometimes you just analyze the image and then throw it away because it's too much to have at the same time. The other approach that we are looking forward to explore more is the nearshore image detections. This can be like cameras in fixed position near the coast. Also can be drone images. The difference between the two is that drone, you fly it one day and then save it a little bit more for another occasion. And the fixed cameras, it should be like collecting the images constantly through all the day. And if you have light on the night, but we are not exploring that part right now. And the advantages of this kind of system is that you will have real-time images. The camera, you can connect with it. You can do process alive while you are getting other images. So it's required less computer power because of the image is much smaller. So you don't have to worry about that kind of storage and process the power computing. And the disadvantages is compared to the satellite images, there's small area analysis. You cannot analyze like kilometers around. You just have to really think about what are you going to study or what do you want to decide to see and focus all the cameras to that kind of imagery. There is few ideal locations. It's difficult sometimes to encounter like a high place with electric one and also like with internet. So it gets like a little bit difficult that part. You can see our first images from Port Royals station. We have put now a camera piece there. Yes, thanks to our UV friends. So, and I will tell you a little bit about my master work that we want to apply in all these next stations we're going to put there. So the first part is we modify the image acquisition of the first system we put to study the shoreline. We then modify it to take 30 images in a lapse of 2 seconds. And then getting the mean image of all these 30 images to get like the ripples of the waves to remove them from the image. So in this way, it's like when you have a camera vigilance system, it's like when you are looking for something for a long time, and then you close your eyes and then open again, and then something moves in that the pace of time, you are going to notice that kind of change in your view side. So it's kind of that kind of thing. We want to get like a part of the image that is not changing in that lapse of time. Everything that changed in that part of time is going to be removed by the operation of the mean. So you can obtain like in those 2 seconds is think of, so the sargassum mat doesn't move that much. So it doesn't like move around and change his size, his position. So that way you can remove the waves and get that smoother image to work with. Just is what we call a low pass filter. So everything that moves very quickly is going to be removed. Based on the same things, we are going to get another mean that is the mean of the other image means. That way you can get like an image of the background. There in Puerto Morelos, there are a lot of seagrasses that if you simply use the image, you can mistake the sargass and the seagrass from an image. So one way of getting rid of that like background images is to analyze the background, that is a big mean of all the images, and then subtract the sargassum images from that image, and then you can get a pretty much the confident image, so we can analyze to match paths. One of the part of it is that you get all the things that move around in that part of time. So sometimes you get a boat, like in the first image. Then if there's cloudy and it starts to rain, also the drops in the lens are going to show like movement, like something has changed in that time. And also properly like moving illumination changes can be mistaken by moving things. So we have to adapt a kind of algorithm to get rid of this kind of thing, because we only want to focus on sargassum. So the other part we are doing is like I train a unit, the convolutional network. This is a neural network that works with images, a compression part and decompression part with a convolutional operation between them. So it gets us like it helps us analyze and classify everything in the image. So in the first part of the image, you can see that you can see a little boat there, you can see the roof, and it's moving around the image. And then what the neural network do is he learns from it. You train it with some images. You have to train it. You have to teach him how to decide what to remove and what not to remove. So you have we do a hand classifier around 300 images, so we can tell apart about boats, something like the raindrops and the illumination changes. So after that, you can use it to remove all of this kind of thing and only get the sargassum mats that we saw in the right part. Also, there's not a perfect algorithm for that, so a little bit of the foam has been still there, but almost the entire part of the ships have been removed. After that one part, you then have to identify every mat of the sargassum. I do it like identifying the size of the mat and then the position and also the dimensions of the mat, and comparing every mat in like close images. So we can say, okay, in the first minute, this mat was in here, it was this size, and it behaved like this. Then you look for the next one image and then compare to the size and the movement and the location and all that kind of particular, and we can infer which mat sargassum is the same as the other one, and we can then track his movement around the certain time. So what you can what we get left of is like something like this. You can get like the trajectory of particular sargassum mats, and also you can do like this kind of animations where you can see that we can identify every one of the mats that are moving around the image. The good part about this is that you don't have to rely on the eye or the composition of the image, because you are looking for the numbers in the image. So you are doing a statistic approximation of what is and what is not a sargassum mat. So even if it's hard to see to identify a sargassum mat for the algorithm, is just a question of numbers. So it will be more easy to him to identify it as a human eye. Now, the old set of cameras that we have installed in Puerto Morelos have to be changed because it was high price and it was an old kind of system, so we have to renew it. We designed, as I told you, I've been an electronic engineer, so I started designing and implementing this kind of Raspberry Pi cameras. It's a low cost, and also it's adapted to our needs in the way that we can put and we can program the algorithm to take images for our purposes and for our studies in specific. And also, like, it's a little mini computer in there, so we can do a little bit of the simple process, so we can take much less time and a little bit more of analysis before we have our desktop. And you can see in the right image our free installation here in Jamaica, in Port Royals. They're in the Marine Lab. After 1 day of hard work, we set it up, and it's working and it's looking very good. So we hope that with this installation we can get more knowledge of the people in Jamaica and more support of them, and plant some of these around the country. So what we want to do with this is that we want to do a validation between the two methods. The camera and the station of the coast nav are located in the same pole, so we will have a fairly enough image comparison between them, and so we can go like other places that if they have the same place, we can compare the similarities and interpolate between each other. But if there's a place it's hard to place maybe a fixed camera, maybe then we can place a coast nav station, and with the knowledge we already know about the fixed camera and the coast nav station in the same site, we can then analyze and do another interpretation of the images only with the customer. So that is where we are going to get. And the expected results we want to get with all this work is the improvement of prediction of seaweed arrival boom. Like we want to know how it behaves in different types of lagoons, in different types of shores, and then get better knowledge of the morphology, also of the seaweed distribution, because we have seen that some of the, for example, the sargassum behaves differently depending on the kind of the shore, and also it affects differently the shores that it has been taken up. And for the citizen science, we want to involve the people that are in the process, that are in the suffering the needs that we want to study, and to implement all the knowledge we already have and will be developed in the class of the students. And maybe develop an international seaweed school and community network that our intent is that everyone can talk about what they have in common and have a big community, so they can compare their notes and talk around all this kind of seaweeds. Okay, I think that's all. It's an honor. Thank you all.
Thank you.
Okay, thank you very much. Turn over to the audience for questions. Persons online, if you have a question, you just raise your hand, use the raise hand features, and we'll acknowledge you. Okay. For those in the room, you want to use the microphone so that the persons online can hear us well. So.
Very much. I am, of course, very interested in sargassum. And when you spoke about cleaning up the images, you mentioned seagrass and other things that you have to remove so that you can see the sargassum. Could your method also be used to map seagrasses? In other words, not delete those aspects of the images, but somehow enhance, so we could see seagrasses and other coastal ecosystems.
Yeah, of course. Obviously, the focus changed. You don't have to do the subtract of the image. You stay with the background image, and you focus on that on different time lapse. So maybe you are studying like January for each year, and you can see the growth of the decay of the seagrass around these kind of images. Yeah. Also, you can do like seagrass is not going to change in the time of a day, so you can do mean images bigger, so you can get enough information about the size and the position of the seagrass. So yes, it's possible. We were thinking about something like it in the future. In the future work, so yes.
Thank you.
Thank you.
So I know Portillo is like the flagship location for the stage as the existing stage. Are there other locations that you're interested in installing a station?
Well, ideally, the more station we have, the better understanding we have of the coast of Jamaica. We have another potential site that we will be discussing later, and see if we manage to get at least another citizen science station set up soon, and hopefully a camera as well, maybe with a little bit more time for that. But yeah, ideally, the idea is that if we get people to know the importance of this project and how they may be able to contribute just by they are walking around that day, and I remember to take the picture that day, that's already data that we are able to analyze and to hopefully use some modeling skills to then predict what is going to happen with sargassum. As far when we have the understanding of Jamaica and anywhere else, we then may be able to say, well, this month we expect sargassum come in this direction. How do we do something before it arrives, or how do we prepare the people for this? So that's the goal. So far it's now this process of getting to understand how we do the analysis. Some of the is going to be doing quite a lot of that, and then talking with the people, talking about this. But hopefully it will come much more from this process. Hopefully we keep collaborating as well with you, have the problem in your nose at the end of the day.
How do you make the decision about where to put it?
So the marine lab, for now, as of first station, the decision has been made around the how easy it was to get attention in schools to sort of spread the knowledge already about what we are trying to do. Ideally, a lot of beaches were mostly those beaches that have been badly affected by sargassum. That's where we want to have our stations. But our marine lab, I think, Mona, you're probably best to answer about the marine lab. But my understanding is that it's going to be very easy to get that seeds planted, so people know about why that's there, what's the camera at the top of that citizen science station doing, and what we are hoping to get. Yeah.
So because this is relatively new, we wouldn't really like the word to get out. That we want to do this monitoring. The criteria relate to where we can get the community engaged and where sargassum is causing a problem, where sargassum is coming. And so with the tours coming to the lab, schools already come, our students who go to the lab for their research and their classes. There is a ready supply of persons, and so we hope to build that capacity of knowing what you can do with images and linking it to the problem of sargassum. We hope to get some media exposure, and then these cameras, although they're low cost, they're not free, and so we would love to get a camera on all the main sargassum beaches, especially the South Coast, East Coast, Mansion Hill, Long Bay. We would love to get a system like this on the main sargassum beaches. We have to call them around Jamaica. And so this is a start.
Because of that, we're at some sort of data, it's expensive amount of just us. See how we put the price that having a role in that, soon so probably some here. Concert that, and one that you know, we knew is that Sunday I was in the feed, and I was at feed. And it's also to a feed, and they say, it is affected by sometimes. But then someone came to me and said, there's not an issue that really needs to be bigger. It's the go trading. I mean, if you want to look at camera, you can see that in my picture. So I don't know, they must be really here. People see a camera, I think it's slide right now. So that answer, I wonder if you have any sort of clarity or
So I think that's why the work with the schools and the work like communicating with people, what's happening and why that's there is super important. Because if we manage to get the community on board and they know that's there, they will take care of that themselves, because they know that is a benefit behind that. Or at least that's the experience we got in Ghana, working with the communities there. When we first thought about the idea of just having the citizen science, that is just this metal post, we were warned like the metal post may not be there tomorrow. So we didn't know if it was gonna work, if it was gonna be accepted by the people. But I think it has helped a lot to have the chief of the community involved into this research projects, the children and the teachers. And now, whenever we go back to Ghana, it's just amazing how they all know who you are, and that they keep taking pictures all the time, those stations, so they are thinking there, they really think they are making a difference. So I think that's where we want to get in Jamaica as well. So that's what we need to transmit that information, and that would be hopefully the goal. So low tech would be to have a citizen science, and what Pepe Toño will be doing soon is trying to see by, so that's why we have the camera and the citizen science post in the same location here in Jamaica, but we don't have that anywhere else in our locations, yeah, here. So if Pepe Toño is able to prove that with the citizen science, we actually get the same information that having technology installed, then that's it. That may be the solution, and it's quite cheap. Just require the person having that willing to make the picture. Do you want to ask anything there?
Yeah, I think the main focus is that the people in the region embrace this as a project of theirs also. So they feel that they can participate and take part of it. It's a part of it. And also that security, that we are not using it for laws or so that kind of no important things. That is something for them and only for them and us as together, work together.
I don't know if you want to get an estimation exactly of how much the camera is. Yeah.
Yeah, I mean in US dollars it's around converted that 500 something like that.
It's not that expensive.
It's not expensive, like one, I think it's 100,000 Jamaicans, something like that. Yeah.
It's expensive.
Yeah, it's relatively low compared with I think the original system that we had in Puerto Morelos had something like $44,000 something like that. So in comparison is so yeah. Thank you. You're welcome.
Thank you for your presentation. Just to piggyback on what Carpona did, motivation and working with schools, mentioned that in Ghana, that part of the project side of the installation was to their materials for the science teachers work with. And our team has been doing a lot of communication, social media, and otherwise. But we've been working with the team to do repair sessions here, which should help us to kind of broaden more camera installation. We have time for that, and we'll get it.
So we visited the Royal Primary School. We came with the type of material as an example, the one that we developed for Ghana, to try to see what would they think if they could implement something like that into their teaching, or how they would like to go around that. So Chantal is probably also an interesting one to keep answering here, but I think we are going to be working closely together to try to develop activities and try to bring that knowledge of sargassum farther. So see if we can as well, as soon we understand better how to use the images, it would be actually very nice to show the community what we are doing with those. So you are taking the picture, so what's happening next? Can we show you what's the project? So that thing, so try to communicate every step we go on the science, try to communicate that with the people as well. Chantal, do you want that?
So the answer is when we shared the lesson plans for other primary, one aspect is general information as somebody who goes to the school community, impact of that is silence. But one of the biggest things that the teacher is that the existing template that we shared with them, some of the activities that are there are already tied to the teaching curriculum for the national education plan. So that was a big plus for them because they want to know what kind of system in teaching students something that is already established. And a lot of the activities are interactive, so they also let us say, looking forward, we have a plan where program will come to the lab probably on a monthly basis, do the sarcasm activities. And so we're basically assisting the teacher with that as well. So what is the impact of sarcasm on the environment, what kind of animals we find in sarcasm community? Those are some of the things that are already incorporated in that list. So we're just looking to modify it because the teachers will know what best works with their students, and then we take it from there so that you don't have their engagement for part of the teaching.
And
Yeah, so all the schools, so the primary school is one, but we also get the high school, so they know we can look into one of the lessons plan, having like classification of science. And then that now ties into the biology, C-set curriculum. So we will modify it based on the pieces that come to the lab, but we already have a starting point.
Something is something is they have the same. They say just in when it starts somebody for so very important because most of the fishing communities don't have one sort of thing. And if they knew that this time fishing is gonna go wrong, they could then plan their lives so that they could focus on the other sources that you want. So we are not just this for it's very important. This is something I see that humanity impact on the lives of
And just to add, that's an excellent point, Dr. Bragg. There is also a growing interest in using sarcasm. And there is one company, one group that has been asking about, can I tell them when it will come and where it will come? Anything that if you're a business person, you don't want to scour the island and know whether you will get sarcasm or not. So anything that will help with the predicting of where you're likely to get large enough amounts. Janelle has worked on quantifying how much sargassum comes on a beach. They want you to tell them, can I find it? How much of it will I get? Where am I likely to get enough to drive my business? And so it's very important.
A small comment as well following what you said. I think it's important to highlight, I don't think we have done it, is the fact that for the citizen science camera, not the camera, sorry, the low cost one where anyone can take the picture. Yes, we need to encourage the people to take it. Doesn't matter if there is sarcasm or not. So the idea is that we also understand when there is no sarcasm. Okay, so we can actually link the condition of the current, the condition of the wind, everything that we can to then be able to estimate better. Because sometimes we think, oh, there is sarcasm, I make the picture now, but it's equally important to have that data when we don't have sarcasm. That's the only way we can train better our predictive models.
Right, we seem to have all the questions from the room. Are there any questions from online? Okay, well, then. I guess it's just for me to say thank you very much to our presenters. We appreciate it, and I think we had a lovely discussion afterwards. So thank you very much for coming, audience who turned up in this week before classes started. We appreciate your coming. Have a good afternoon, everyone.
Yes.